In this question, we're trying to determine the final velocity of a gumball machine after moving 1.9 meters. We see that the gumball machine is being pulled at an angle to the horizontal, and the gumball machine will move along the horizontal. This means we need a force applied y in order to determine the normal force. Force normal is going to equal 4.8 times 9.8 minus the applied force 18.6 times the sine of 16.5. Force normal is going to be equal to 41.8 newtons. It's always good to get force normal done separately in order to keep the conservation of energy equation as simple as possible. Okay, let's determine what kind of energies we have. Assuming that it starts from rest, we ask ourselves, is it moving? And the answer is no. So therefore, there is no kinetic energy. The origin will be placed on the ground or the lowest position always in these questions. So we ask, is this above the origin? The answer is no. So then there's no gravitational potential energy. Are there any springs attached that will push or pull on this object? I don't see any there, so elastic potential energy is no. Finally, we ask, is there an applied force, and is it going through a distance with that applied force? Well, there's an 18.6 Newton applied force going through a distance of 1.6 meters. Therefore, there is work done. I will give it 4 boxes of work done here. Now remember, the choice of boxes and the number of boxes depends on the type of energy present, but I always choose 4 at maximum. Now, after this is pulled 1.9 meters, that'll be our second condition. We ask ourselves, should this object be moving? And the answer is yes, of course. We are applying it through a distance, so it should be moving. So there is kinetic energy. So I'll click those 2 boxes. Is this object above the origin now after it moved 1.9 meters? And the answer is no, it was sliding on the ground. Therefore, it does not have any gravitational potential energy. Are there springs attached? I still don't see any springs attached, so no elastic potential energy. Is there friction involved? Okay, well, I see a coefficient of friction here of 0.18, and we are sliding, so it is reasonable to expect that there would be some friction. So there is some thermal energy loss. And again, I'll just give it 2 boxes. Now remember, this is just a graphical user interface, more or less, to help us know whether or not what kind of energy is present. So I give 4 boxes to work, and I just share 2 boxes with kinetic energy and 2 with thermal energy found. So the equation then, our conservation energy equation, I'll write over here, work is then converted to 2 kinds of energies, kinetic energy plus thermal energy. Okay, now our job is to plug numbers into each one of these according to their equations. Well, I know work is force times distance times the cosine of the angle. So I'm going to put 18.6 as my applied force. The distance we're going is 1.9 meters, so I'll put my 1.9 meters there. And then I've got an angle of 16.5, so then I'll add the cosine of 16.5. I'll set that equal to the kinetic energy. Now, kinetic energy, of course, is 1/2 mv squared, and I think to myself, well, what am I finding in this question? I'm finding the velocity after 1.9 meters, so I will have to find that within the context of the kinetic energy equation. So I'll say 1/2, and I'll look at the mass, and that's 4.8 meters. That would be 4.8 kilograms. And then I will just say 1/2 that times the velocity squared, and I don't know the velocity. So that becomes my variable. And now I need to plus the thermal energy. Well, I know I need my force normal now, so 41.8. That's force normal. And then I multiply by my mu, and that's 0.18. And then I say, well, how far did it slide? Well, I look back here and I remind myself it did slide 1.9 meters. So I go 1.9, and I fill that in there. And here's my equation. Now I need to be careful and do my algebra correctly, and I will solve for velocity in the end. Okay, and that's 2.86 meters per second. Okay, and that means it'll be traveling 2.8 meters per second after it moves a distance of 1.9 meters. And there it is.